Hello everyone, welcome back to another geostats lecture video. And in this lecture video, I want to go through the equation of the spatial lag y model. Now I've left the spatial lag x model there because what we're going to see is it's going to actually be very similar, but there's going to be one key difference, and that key difference has to do with the lag y versus the lag x. And so to quickly recap, right, the spatial lag y model is built on the premise that the dependent variable of my neighboring regions is going to have an impact on my dependent variable. So in this case, the y is playing double duty, right? We're predicting my y, but we're doing that based on information provided by my neighbor's y. So hopefully that makes sense. And so the equation again is going to look pretty similar. I'm actually going to give myself just a little bit more room here so that we can not be too muddied. And again, right, we're going to have our y. So this is our predicted dependent variable is going to equal our beta naught, which is our intercept, plus our beta x. And then again, I'm going to leave a little bit of space here, plus the error term. So rather than redrawing all of these things, I'm just going to draw some lines here, right? Because again, right, this is the error term. We have our independent values. We have our beta slopes, which relate the independent variables to our dependent variable. We have our beta naught, which is the slope, or sorry, which is the intercept, which is what happens when all of our independent variables are 0. And then we finally have this predicted y. Okay. So the thing that makes the spatial lag y model different is this inclusion of the variable rho, which I can never seem to draw without it looking like a p, but this is rho, times the weighted mean of y. And so you can imagine here, I shouldn't even say imagine, right? This is true, right? So this is the lagged mean of the dependent variable. Right, and again, when I say lagged mean, I'm going right back to that idea of spatial autocorrelation when we calculated the lagged mean, which is literally just the average of your neighbors. Okay, so this lagged mean is just the average of my neighbors based on some definition of adjacency. And then this other piece right here, this rho, and I'm gonna actually write it out because I can never draw a rho properly, right? This rho, right? This is just the slope, right? So this right here is the same as the theta is the same as the beta, but rho in specific is talking about the relationship between our y, between the thing that we care about for us, and the y value of our neighbors. Okay, so hopefully that makes sense. So what I want to do is wrap up this video. I'm going to scroll up just a little bit so that we can kind of see both equations a little bit more in focus. We're going to talk a lot more about this in the next video, but I wanted to sort of lay the groundwork here while we're looking at the equations, is the idea of direct and indirect effects. Right? And so if you think back to our original ordinary least squares model, when you had these betas, if you think back to our original least squares model where you had these betas, and we said that the betas were the relationship between x and y, and it represented if you had a 1 unit change in x, what would your unit change in y be? The way that that's described is what's called an effect. Now, here's the thing. With the spatial lag models, right, because we now have these mean neighbors here, right, we can no longer directly interpret these as the effect, right? Because changing our x here also impacts our neighbors here. So what we have to do is we have to separate these out into direct effect, right? How my change affects me, and indirect effect, which is how my change affects my neighbors and how my neighbors' change affects me. And to get what's called the total effect, we have to do a little bit more work. And that's going to be the topic of the next video. But I just wanted to sort of point out with these equations that we have the direct relationship and the indirect relationship. So hopefully that makes sense. And as always, please reach out. Thank you.